Okay, so today we're going to talk a little bit more with operations. So we just got done talking about operations with complex numbers, all those that had real numbers and imaginary numbers with it. So now we're going to take that and apply it to a new situation, because usually when we talk about all different types of functions or equations, we usually talk about their operations. And this might be a little bit of review. We may have done it a little bit in Algebra 1. It's okay to review it because it's important, because we do a lot with polynomials for the next month or so. So first thing is, again, operations. That means we're going to add, subtract, and multiply these today. There is division, and we'll talk about that in a little bit. It's just like with division with complex numbers, I separated that out. There's a little bit of a difference with when we divide with polynomials, so that'll be its own separate lesson. So today we're just focused on adding, subtracting, and multiplying with a polynomial. So first thing to define is what the heck is a polynomial. And that just means if you're working with an equation, your equations are going to have x's with exponents. Usually that x, like when we were talking about a quadratics, those were polynomials because we had x squared and x and a number. But again, what a polynomial is just many terms, is technically what it's talking about. The other thing it's also defined as, it's a sum of monomials. So monomial will just be one thing. And we've talked about that a little bit already. When we were factoring, we factored trinomials, because a quadratic had 3 different terms. So with polynomials, we just have an equation that has many terms. So each individual part of the equation is called a term. So like we could have an equation that has 4 different pieces. So it'd be like 3x to the 4th plus 5x squared plus 3x minus 1. So those are 4 individual parts of the equation. So each one of those things is called a term. So sum of monomial is just everything that's separated by addition or subtraction. So there's some things that a polynomial can't have, because we have all different types of equations, and so we're specifically talking about a polynomial. There's actually 5 things that your equation can't have in order for it to be a polynomial, because in order for it to be a polynomial, we just have to have one variable, and we can give that variable an exponent, but we can't give it, there's certain exponents it can have and certain exponents it can't. So here's the first 2 things that you can't see in a polynomial. So if you have an x with a negative exponent, that's actually a different type of function. It's just not a polynomial. So it can have positive exponents, it just can't have negative exponents. You also can't see any square roots. Again, that's a different type of function. We'll talk about these things later. But again, if in order for it to be a polynomial, the x has to just have a positive exponent, and it can't be a square root. There also, if there's a fraction, fractions are okay, but if you look at the fraction, a variable can't be in the denominator. So it has to be like 3/4. It can't be 3 over x. So if you see a variable in the denominator, it's not a polynomial. Also, you can't have different variables. So you can have all different varieties of x. So x could be squared, x could be the 5th power, x could just be x, but you can't have an x and a y. So that's what I mean with multiple variables. So if you have an equation with x, that has to be the only variable that you see. So you can't have an x squared and then a y later. That's not a polynomial. And then also for your exponents, again, they need to be positive whole numbers. So you can't have negative exponents. You also can't have a variable in exponent. So you can't have x to the x or 2 to the x. Again, x has to be the base, and then your positive whole number has to be your exponent. So I think we'll actually use these more later, but again, just kind of introduce you to some of the new vocab with polynomials. There we go. So let's go on to a couple more vocab things. So the big thing that we focus on eventually, and we'll do a little bit here, like I said, eventually after I get through some of the vocab, we're going to focus mostly on operations, is something called the degree of the polynomial. And if we're classifying polynomials by degree, we just look at its greatest exponent. So like when we were working with quadratics, we had an x squared in there, so its degree is 2. So, and we're actually going to use that phrase still. So all the quadratic stuff we did will carry over to polynomials. So if we have x to the 3rd power, its degree is 3, and that's the highest exponent. If we have an equation where it's x to the 6th power plus 2x x to the 5th, plus 3x minus 1, the x to the 6th power, the 6 is the highest exponent, so we'd say that it would be degree 6. So it's the biggest exponent, it's pretty self-explanatory. Like I said, each individual piece is called a term, so if you're classifying by number of terms, just count up how many pieces you have. So if it was, like I said, 3x to the 6th plus 5x to the 5th plus 2x plus 5, that would be a 4-term polynomial. So each individual piece in between the addition and subtraction signs is a term. So if you're classifying by number of terms, you just count out how many pieces of the equation you have. And then the other thing that we use when we're talking about polynomials, and this will come into play when we go into our operations, is there's a certain order that we list our terms. So if I ever say, is it in proper order, that just means you need to make sure that when you list your terms, you always start with the term that has the highest exponent and then work your way down. So that way when you look at the equation, the first term should be the biggest exponent, so therefore it's easier to classify the degree. So if it's not in proper order, usually you'll see this direction within a problem. It says write in standard form. What that means is just make sure that the polynomial is in order. So make sure you start with the highest exponent and work your way down. So for instance, this little polynomial I have written here, the original way I had it written with 3x to the 2nd plus 4x to the 4th plus 6x, that was not in correct order because the highest exponent did not come first. It was kind of stuck here in the middle. So if you see write in standard form, all that's asking you is just kind of reorganize your terms, and so that the 4x to the 4th is first, then the 3x squared, then the 6x. So you start with the highest exponent and work your way down. So 4, 2, and then there is an exponent here, it's 1. So if you ever have just x in your equation and that's the biggest variable that you have, then its degree would be 1. Because remember, there's always an exponent of 1 if we don't see it. There's a couple little vocab things. So now what we can do with this is just, I'm going to give you just some equations, and you're going to say, is it a polynomial? And then you're going to check these things out. So if it is a polynomial, I want you to say what the degree is. And a lot of times I'll put write in standard form, but I know for a fact that all these examples I gave you already are. So if I know that they're already in standard form, then I'll omit that direction, but if they're not, then just make sure that you rewrite them so that they are. Okay. So we'll focus on this first one. So here we have, this is a polynomial, it just has 2 terms, and again, it doesn't have to have x, so we have p as our variable, but notice it just has the variable p. Again, p can be to the 5th power and to the 2nd power. We don't go from p and then the second variable is an x. So it keeps the same variable, so we don't have multiple variables. All the exponents are not negative, so they're nice positive whole numbers, which is what we want. The fraction that you see, notice it just has a 4 in the bottom, not a variable. So it doesn't have any variables in the denominator. It also doesn't have any square roots. So then this one is considered a polynomial because, again, there's no variable exponents, no negative exponents, no square roots, and no variables in the denominator of a fraction. So if you see a fraction, if you look down there, there's just a number, then it's fine. So yes, it is a polynomial, and so then we're going to say what its degree is. So its degree would be that 5. So degree is 5 because 5 is the biggest exponent. So there's the first one. The second one, again, this one, we don't have different variables because just x. There's no square roots, but if you look here at this middle term, we do have a negative exponent. So even though we have a nice exponent here, as long as one of the terms has one of the things that a polynomial can't have, this is considered not a polynomial because of that negative exponent. So what I should have typed up here is usually if it is a polynomial, I have you state the degree. If it's not a polynomial, then I just want you to tell me why. And so you don't have to necessarily use it full sentence. Usually I like that, but here I didn't. So no, it has a negative exponent. You could also circle the term that again, some sort of indication of why you said no. So there's the first little bit. So a little bit of vocab to start with, but now we're going to get into our main focus for this part of the unit, and that is operations. Like I said, we'll eventually revisit more of this vocab, and you'll see this a little bit, but again, it's kind of important as we do more stuff with polynomials to get kind of some of the basics. So here's the next little bit. So with adding, and adding mostly with any type of equation that we talk about, you do want to add like terms. So with adding, you can only add likes with likes. And so when you do that, what are like are stuff that has the same variable component. So if you have an x to the fourth, it can only be added with other x to the fourth. And you just total them up. So when you're adding stuff that has exponents, the exponents do not change. You just total up how many you have. So if one polynomial you have 2x to the fourth, and the other one you have 3x to the fourth, you're going to total those up, so you'd have 5x to the fourth. So the exponents don't change, you just total up how many you have. So here we go. So one polynomial is grouped here. Again, parentheses, just like with complex numbers, is not always showing multiplication. Because notice we have this big plus sign here. So it's grouping. Here's one polynomial. This one had 3 terms, 5x squared plus x minus 7. And here's our second polynomial, 3x to the third minus 2x minus 1. Okay? So we're grouping, the parentheses are grouping those together so that this is our first polynomial, here's our second. So then what it asks us to do is what you see in the middle, and that's just add. So we can only add likes with likes. So we have this 5x to the second. It cannot be added with this 3x squared because this one has an x or 3x to the third power because we have x to the third power and x to the second power. Those are not like terms. These two things cannot be added together. What could be added together is this single x. We have 1x here and this negative 2x. Those two things can be added together. And then same thing for the 7 and the 1. Those two are just regular numbers. So those two things can be added together. So the 5x squared can't change. The 3x to the third can't change. But when I add x plus a negative 2x, I have negative 1x. Which you could write the 1 there if you want. I didn't. But if you wanted to, you could put 1x there. Then I took negative 7 and I added negative 1. Since they're both negative, it remained negative. And then we also have that 3x to the third power. So then once we add, the only thing to do before we circle our answer is make sure that we have it in standard form. So we want to make sure that the highest exponent comes first, which the way I have it written right now, it's not. The 3x to the third is written here at the end. It needs to go at the beginning. So before I circle my answer, I'm just going to rewrite it so that it's in proper order. So the 3x to the third should come first, then the 5x squared, then the negative x, then the negative 8. So that would be my final answer. Now most of the time what I do, as I'm going through this, so I don't have to rewrite it a bunch of times, is I noticed that these two couldn't add together, but I did notice that this was the highest exponent already, so usually what I do is go ahead and write that first, even though I didn't change it any, because I know that that's the highest exponent, that'll come first in the end, then go to this one, then go to the x, then go to those. So you can kind of do them in order as you're going, so you don't necessarily have to do it a bunch of different times, so you don't have to rewrite it a bunch. So that's what I would have done, just gone right here, put 3x to the third first, then 5x squared, then negative x, then negative 8. So there's adding that first one. So let's do a quick second example. So here we have x to the fourth, there's one of those. And then over here we also have x to the fourth, so we're going to add those together, so we'll have 3 of those. So it'll be 3x to the fourths, because we have 1 here, 2 here, so it's a total of 3. This 2x to the third doesn't have anything like it, so it's going to stay the same. And then we can add the 8 and negative 9. So if you look at my answer, here's 1, we had, like I said, we had 1x to the fourth here in the first polynomial, we had 2 over here, so we added them together and made 3. The 2x to the third didn't have anything like it, so it stayed the same, but it goes next in order. So I wrote plus 2x to the third here, and then I added 8 and negative 9, so we got negative 1. So there's our adding. Subtracting will be the same way, or subtract like terms. Again, the biggest thing with subtracting is making sure you're watching your negatives. So let's look at some examples of that. Again, we're subtracting, exponents don't change, we're just totaling how many we have. Now we're subtracting terms instead of adding. And again, make sure you subtract all the way through as you're going through each problem. So we're going to look at a couple of examples. So here we go. We have 3x to the third, 8x plus 8x squared minus x minus 5, and then we're subtracting 5x to the third plus x squared plus 17. So we have some like terms. We have several like terms here. We have 3x to the third and 5x to the third. So now we're subtracting those. So we have 3 and we're going to subtract 5, so we get negative 2 for our first part of our answer. This 8x squared, we're going to subtract with this x squared, so at 8 minus 1 is 7. This negative x isn't going to change because there's nothing to subtract from it. And then we have negative 5, and we're going to subtract 17. So again, since we're taking negative 5 and subtracting 17 from it, it's going to get more negative. So that's why in our final answer, we have negative 22. So again, we took 3x to the third, subtracted 5x to the third, so we got negative 2x to the third. We have 8x squared, and we subtracted 1x squared, so 8 minus 1 is 7, so we have a positive 7x squared, because again, 8 was bigger, and it was positive, so it remains positive. Subtract 1 from it. The negative x did not change, and then we had negative 5 minus 17. So negative 5 subtracting 17 should get a bigger negative, so we have negative 22. So the big thing to remember is the subtraction carries through to everything behind it. So I know it's kind of a little bit tricky because we have these extra plus signs in here, but remember, kind of individualize them. Like I said, if it helps, cover up and just look at what you're looking at, or look at what you're focusing on. So if it helps, you could have covered up everything but the cubes and so subtract those, everything but the squares and subtract those. So you can just make sure you're watching your signs. So let's look at another one. This one's unique because, like I said, the subtraction is going to carry through everything behind it. So we didn't have to worry about it too much about this first one because every one of these behind it had a like term. But every once in a while we'll have something that doesn't have a like term, like this x that I notice. It'll also need to be subtracted, so you'll notice the subtraction is still going to affect everything behind it. So I'm going to do this one a little bit different. So I'm going to go ahead and show you what I got for my answer. So we have 9x to the fourth, and I have 3x to the fourth, and subtracted those. So 9 minus 3 is 6. That's where I got the 6x to the fourth. Then here we have 12x cubed, and we're subtracting another 12x cubed. I know it's very tempting. A lot of people want to say that's 0, but again, since this negative, just 12 is negative to start with, and then we're subtracting 12 more from it, we get negative 24x cubed. So that's why you really just have to be careful with your negatives. Make sure you're careful and subtract properly. So then we have x squared, there's nothing to subtract from it, so it stayed x squared. But if you notice, this next one, because I like to write it in order, the next thing in order would be my x. Sorry, my phone rang, so I had to interrupt myself. So here we go. So like I said, where I was at was this negative x. So the subtraction, even though there's nothing to subtract from it, like I said, does carry through behind it because it's like nothing minus x. So the big thing to remember is the subtraction carries through to everything behind it. So that's why this changed to negative x. And then we have negative 8, and we subtract nothing from it, so it stays negative 8. So anything in front of the negative, like this x squared and the negative 8, doesn't change. But anything behind the negative will change because it's behind that negative. So think of it as almost like a distributing. That negative will go to every single thing behind it as you're subtracting. So we took 9x to the fourth minus 3x. Negative 12x cubed minus 12x. So just make sure you're careful with your subtraction. Okay, so now we're going to do some multiplication. And again, with multiplication, just like with complex numbers, you multiply everything together. So since we are multiplying stuff together, that is when you're going to change exponents. Just like when we took I times I, it became I squared. Whenever we take an x times another x, the exponent should always increase. So we add the exponents. So if we have x squared times x to the third, it's x to the fifth. X times x is x squared. Now, whenever we do that, again, I squared was defined as something else because I was technically defined as a number square root of negative 1. So that's the only time we worry about that. So if we get an x squared, it stays x squared. So you just have to make sure you remember that. So here we're going to multiply this. So we have 3 terms in this polynomial, and we're multiplying this one with just 2 terms. Now again, notice all the problems are going to look similar, but notice now there's nothing in between these 2 parentheses, so then that tells us we are going to multiply. So if you see addition in between it, just add, subtraction, just subtract. Here, we're going to multiply. So we're going to take 4x squared times both of these, x times both of these, and negative 5 times both of these. So you have to multiply everything together. So to kind of help separate this out, I wanted just to show you the problem, but then I always usually use my lines as a multiplication. so you can see where everything's going. So like I said, you take 4x squared times both of these, x times both of these, and negative 5 times both of these. So you're all the way out. So we have, well, we take 4x squared times 2x, so we can take 4 times 2, so that's where the 8 came from, so you multiply the numbers in front. But if you take an x squared times an x, since there's, like I said, I wrote, usually if there's no exponent, there's a 1, so sometimes I write that in, so we're going to add the exponents. So if you take an x squared times an x, it becomes x to the third power. So that's the 4x squared times the 2x. So then we also take 4x squared times 1, which that's just 4x squared. So that's where this term came from. Now we're going to take this x times both of these. So we take x times 2x. So that's 2, because again, this is like a 1, so 1 times 2 is 2. And then an x times an x becomes an x squared, because both of those have an exponent of 1. Add those exponents, so that's where we get the 2x squared. Then we take x times the 1, which x times 1 is just x. Then finally we have to take negative 5 times everything. So negative 5 times 2x is negative 10x. So since 5 didn't have an x, the exponent didn't change, it's just stayed x. Then take negative 5 times 1 is negative 5. So then when you get here, it's back to simplifying. So if there's any like terms, you can combine those. And again, when we're combining like terms, we just total up how many we have. So we do have some like terms. So these x squareds, we can total those up. There's going to be 6 of those. And here we have a 1x and a negative 10x. So that's going to combine to negative 9. So the 8x to the third should come first, because we have to keep that in proper order. That didn't change because there's no like terms. We combined our x squares. Squared. We combine our x's, so it's negative 9x, and then negative 5 at the end. So there's our first multiplication. Alright, second multiplication. Sometimes there's not quite as much to multiply, so here we just have the 2x to the third. We just need to take it and distribute it to all 3 of those terms. So again, we're going to multiply the 2 times the 5, and then add the exponents on x. So that becomes 10x to the fifth. Then we take 2x to the third times 3x. So we have 2 times 3, which is 6. X to the third times x becomes x to the fourth. Again, anytime we take an x times another x, the exponent should always increase. Then we take 2x cubed times negative 1. We get negative 2x cubed. So there's our second multiplication. So, like I said, the big thing to remember is to make sure that with adding, you just total up everything. Subtracting, watch all those negatives. With multiplication, you have to multiply the numbers in front and add their exponents. And then we have one more thing with multiplication that we're going to cover, but again, it should go pretty quickly. There's a little bit more of a definition here. So this is called a square of a binomial. So to dissect the phrase, square, there's going to be an exponent of 2. So when you see that word, square, not square root, square is an exponent of 2. A binomial is going to be 2 terms. So something like this. Again, it doesn't matter what's in there right now. This is to show you this binomial. There's 2 things in there, and then the whole thing is squared. So that's why it's called the square of a binomial. So the big thing that we do with this, and we see this quite often, especially as we get into more upper level stuff, when you have something squared, it's not the same thing as multiplying it by 2. So you can't just distribute exponents, because what that exponent is telling you to do is take the base times itself. So that's why when you have 4 squared, it's really 4 times 4, which is 16. When you have 5 squared, it's 5 times 5, 25. So it's telling you to take this, whatever the square is attached to, times itself. So you must take a plus b times a plus b. So you can't distribute an exponent. So whenever you have something squared like this, it's actually just a multiplication. So we have to FOIL it. And so we're going to have to take everything that from the first parenthesis times everything in the other. So for instance, most of the time what our situation is going to look like is x plus 3 squared. So again, we can't just distribute the square. We just have to take it, because what x plus 3 squared is actually telling you is take x plus 3 times x plus 3. So we just have to multiply it. So we have to take both of these times both of these. So we multiply it all out. So we'll take the x times the x, which is x squared. Then take x times 3, which is 3x. Then take this 3 times x, which is another 3x. and then take this 3 times this 3, which is 9. So it kind of follows a similar pattern that our complex numbers multiplication did. So it's x times x, which is x squared, x times 3, which is 3x, 3 times x, which is 3x, and then 3 times 3, which is 9. So then we can combine like terms, which if you notice I've underlined those. So our final answer can be x squared plus 6x plus 9. So, like I said, we mostly focused on the operations. Hopefully all that made sense. We did a little bit of some vocab, which we'll continue to integrate as we move forward in the unit. So we're just focused on adding, subtracting, multiplying, a little bit with the degree and what makes it a polynomial. So hopefully it all made sense. I'll post a PDF of this as well. So just let me know if you have any questions.